Geometry students, we are going to talk about some transformations. We have had some experience with this in algebra. There is definitely a big algebraic component to this. I don't know that we're going to necessarily exploit that in this particular section, but we're going to focus on recognition. So a transformation, basically the basic definition is if you change the position, size, or shape of a figure, you've transformed it. Okay, we're going to talk about 3 of them. There's actually 4. I don't know why textbooks don't do this, but there's a 4th transformation called a dilation, where you can enlarge a figure or shrink a figure. It doesn't change, the figure itself doesn't change, it just gets bigger or smaller, and that's a dilation. We're going to talk about 3 basic ones today, and then the section, reflection, rotation, and translation, all of which we have had experience with in algebra. We've solved them algebraically. Now, the original figure is the pre-image, and you'll notice that, we would call that ABC, triangle ABC. The resulting, after you have transformed it, the resulting figure we call the image. And notice the tick marks that are beside A, B, and C. Okay? We use that they're called primes. We use those primes very specifically to indicate, what happened after the transformation occurred. The pre-image is triangle ABC, and then after the transformation, it's triangle A prime, B prime, C prime is how you say it. Arrow notation is that arrow that's between triangle ABC and the other triangle A prime, B prime, C prime. That arrow indicates that a transformation has occurred. So as you're looking at the very bottom there, that box, the reflection is a flip. Okay, we've got a line of reflection and it's literally flipped over. Each point is the same distance from that line of reflection. So that's what you're looking for, is having equal measurements basically in that change. A rotation means we're turning. It's turning around a certain point called the center of rotation, and all the points are the same distance from that center of rotation, not necessarily from the line, but from the center of rotation. And then a translation is where you're sliding the figure up or down, right or left, but all the points are moving the same distance and in the same direction. So that's what this front page is about. Let's get to the second page. Now, example 1, we're identifying the transformation. So this is where, can you tell, just looking at it without numbers, without manipulating it algebraically, can you tell what's going on? And then we're going to use arrow notation to describe the transformation. Okay? So as we look at this, we've got these 2 triangles here. This is our pre-image here. Okay, and then with these tick marks, these primes, this has to be our image. So something clearly has happened, and we have to identify whether it was a reflection, a rotation, or a translation. Now it looks like we have kind of a center line here, kind of a line of reflection is what it looks like, and it looks like it got flipped. Is what happened. It got flipped over this line. And so all the points, F is the same distance away from that center line as F prime. E is the same distance from E prime from that center line. And same thing with G and G prime. So what we think this is, we think we have a reflection. And this is how we would write it. We would go triangle E, F, G, and then was transformed or reflected and became triangle E prime, F prime, G prime. And so that's how you want to identify the transformation. Tell me it's a reflection, And then this is how you write using the arrow notation. Arrow notation is this part right here. That's arrow notation to show what it was. So we did two things. We identified the transformation and then we did arrow notation. Let's look at letter B. Again, same directions. Identify the transformation and then we have to use arrow notation to describe the transformation. So this time it doesn't look like we have a reflection, okay? This looks a little different. This looks like, see how that looks like a rotation? So I think this is a rotation. It has definitely an appearance to that. And there was a point that it looks like it's rotating around. So where that point is, I don't know where it is exactly, but if it's a rotation, then each of those points on these rectangles are the same distance from the point of rotation. So actually it wouldn't be going this way, it would be going that way. Sorry, this is your pre-image, excuse me, and it would be going up to, ignore that, going up to, kind of rotating up to, this is your image, okay? So that's what it would look like ultimately. So R would be the same distance away from that point of rotation as R prime. S is S prime, T is T prime, U is U prime, okay? So if we're going to write this statement now, looks like it's a 90-degree rotation, looks like, and we're going to start here with, we don't have to write any kind of symbolism when it's a rectangle, so we're just going to do RSTU, and then here's our arrow. There's no symbol for rectangle, so RSTU, and then follow suit with the other one. R prime, S prime, T prime, U prime, just like that, okay? So we identified what it was, 90-degree rotation, looks like 90 degrees, doesn't it? And then the arrow notation.